So we're looking at the geometry midterm practice test right now. Question 1 asks us to classify each figure as a line, ray, or a line segment, and then show how to write it. For this problem, I'm not too focused on how you're writing it. I want you to be able to tell me, is it a line, is it a ray, or a line segment? So our first figure is a line because it goes on in both directions to infinity. So that is a line. And if we were to write this, we would say TU, and then we would put a line on top with arrows on the ends showing that it goes on forever in both directions. Number 2, we have a ray because it has an endpoint and it only continues on in one direction to infinity. If you see that here, we have Q as our endpoint and it goes on forever to the left. So we are going to call this a ray. And to name rays, I use my 2 letters again, and I put the arrow on top in the direction of which the line is going. So it is going from Q to P, so I have the arrow going towards P. And then lastly, we have a line segment because it has 2 endpoints. When it has 2 endpoints and does not continue on forever in both directions, it's called a line segment. And you can think of it as a piece of a line that we pulled out, kind of like a pool noodle where it ends, where it stops on both ends. And to say that, to name this, we just call it SR with a line on top. So on question 2 here, we're given a couple sets of lines and it asks us if they're parallel, perpendicular, or neither. So just a quick review. Remember, our parallel lines are like railroad tracks. They will never, ever, 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 ever cross. Our perpendicular lines, they will cross, but what's important about them and why they're perpendicular is they will form a right angle. Kind of like the intersection of locus and 18th. They all form right angles. It's a perfect intersection there to make the right angles. So if you look at graph 1, yes, they intersect. But they are not perpendicular because they don't form that right angle. So number 1 is going to be neither. But then graph 2 is a great example of 2 perpendicular lines because right here it forms that nice perfect L there, which is our 90 degree or our right angle. So graph 2 is going to be perpendicular. Graph 3 has 2 lines on there. They're not intersecting yet. They're also not perfectly parallel because eventually if I were to continue this line this way, they would cross, but it wouldn't be that perfect right angle. So this is a neither. And then lastly, graph 4, we have our nice, lovely parallel lines here because they're like railroad tracks. They'll never cross if they continue in both directions for infinity. Question 3 asks us to find the location of Q, and it calls Q the midpoint of PR. So if you remember midpoint, that is the exact middle between 2 endpoints. So if we look at P and R, the first thing I did is I went and counted how many spaces were in between P and R. So I said 1, 2, 3, 4, 5, 6. So if I asked myself what would be halfway, then that would be 3 from both sides. So I'd count 1, 2, 3, make my endpoint, and then I can count 1, or make my midpoint, and I can count 1, 2, 3 that way. There's 3 units to the left and 3 to the right, making Q right here in the middle at -8. So question 4 asks us to find the distance between these points. So you will be given the distance formula on your midterm tomorrow on the formula sheet. That'll be the first page of your midterm. And if you recall, the distance formula is D equals the square root of, we had x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And then when you go through and label your points, and this is where you need to be extremely careful, because if you label your points correctly, then you're just plugging it into the formula. and doing the algebra from there. So if we look at the point 6, 4, that has 6 being my x coordinate and 4 being my y coordinate. I'm going to do the same thing for -5 and 4. I have my x coordinate and my y coordinate. They both have an x and a y, but I have 2 points there. That's where my sub 1 and sub 2 comes from. So my point 6, 4, I'm going to call x sub 1 and y sub 1 because that's my first point. It's just what comes first. And then for my second point, the -5, 4, I'm going to call that x sub 2, y sub 2. Okay? Now I'm just plugging into my formula. X sub 2 is -5 minus 6 squared plus 4, which is my y sub 2, minus 4 squared. -5 minus 6 more. And remember, I'm always copying down my square root. I'm not forgetting the squares outside of my parentheses that I need to square it. But I have -5 minus 6. That's going to be a -11 squared. And I'm putting that in my parentheses because when I type that into my calculator, if I have it without the parentheses, I'm going to get the wrong answer. So keep it in the parentheses. And then I'm kind of done there because 4 minus 4 is just 0. And 0 times 0 is 0. So I'm not going to write anything. So I have -11 squared. And -11 times -11 is going to give me a positive 121. And then if you type that in your calculator, the square root of 121 is 11. So our distance is going to be 11 on number 4. Question number 5 is asking us, for the following right triangle, find the side length x. Anytime you have a question asking about a right triangle, you are going to use Pythagorean's theorem. So a little kind of recap on Pythagorean's theorem, that's when you have a squared plus b squared equals c squared, with a and b being your legs and c being your hypotenuse. Your hypotenuse is always your longest side, and it's always the side across from your right angle. So in this case, x is going to be what you're looking for, and that's going to be your c squared. So if we fill in a squared plus b squared equals c squared, what I'm going to say is 8 squared plus 15 squared equals c squared. So then I have 64 plus 225 equals c squared. X being our c squared, to get 289 equals c squared. And then if I take the square root of 289 equals c, which if you type that in your calculator, you get 17. So x, my missing piece, x equals 17. Question 6 here, it's asking the same thing, and it's asking us to round our answer to the nearest hundredth. So if you remember that, that's going to be 2 decimal places. Now, this problem is going to be a little bit different because from my A, B, and C, I'm given B and C, but I don't know A in this case. So from my a squared plus b squared equals c squared, this time I'm looking for a. So I have a squared plus 11 squared equals 14 squared. So I'll continue to work this out. I have a squared plus 11 times 11 is 121 equals 14 squared. 14 times 14 gives us 196. This doesn't look so much like an A, now it does. And what I'm going to do is I want to get a squared by itself. So to do that, I need to move the 121 to the right-hand side. So to undo that addition, I'm going to subtract 121, and that's going to leave me with a squared equals 75. And then now I want to know just what A is. So to undo that square, I have to square root. So A equals the square root of 75, which is about, and that's why I do the squiggly equal sign, which is about 8.66. You don't round that 6 to a 7 because it's a 0 after that. So question 7 is asking us to find the distance between points A and B given below. That is, find the length of the segment connecting A and B. Round your answer to the nearest hundredth. Again, that being 2 decimal places. So if you see on this graph here, we have down here at the bottom, I have where it tells us 1 unit. Yes, it's asking us for the distance of A to B, and we would automatically, our minds would go to using that distance formula. However, this does not give us ordered pairs or a coordinate. We don't have our X and Y axis. So what we have to do is turn this into a right triangle. And how we do that is I will continue to draw, I will extend a line from point A, and then I will extend a line from point B, and voila, we have formed a really pretty right triangle. And we can use Pythagorean's theorem. Remember, you can always use Pythagorean's theorem to find the length of something. We're just finding the length of that side. I know down here, because I count 1, 2, 3, that this distance is 3. And from here I go 1, 2, 3, 4, 5. I know the length of this side is 5. Now I have my 2 legs, and I'm just looking for that hypotenuse. So I will do 3 squared plus 5 squared equals c squared. So now at this point we're just doing the algebra. So 3 squared is 9 plus 5 squared is 25. That equals c squared. 34 equals c squared, but I need to know what c is, so I'm going to do the square root of that. So I have the square root of 34 equals c. So c is about, and I do my little squiggles, which will be my distance of the segment AB, 5.83. I keep it at 5.83 because on my calculator, if I type it in, I get 5.8309. I'm only concerned about that number after the 3. It's a 0, 4 or less. We're going to let it rest, so it's going to stay 5.83. So question 8 here asks us to calculate the distance between points L and points F, and it gives us those order pairs there. If it gives you the order pair, go ahead and use the distance formula. So I'm going to call this x1, y1 because it's my first point. Remember, that's my x coordinate and my y coordinate on my first point. And then my second point I'm going to call x2, y2. My distance formula again is as follows, and you will have this on your formula sheet. And now I'm just plugging in the pieces that I know into the formula and working out the algebra from there. So I have -5 minus, and I'm going to put my minus or my -8 in parentheses again, just so I don't get confused between my minus and negative and see it as one big subtraction sign. And then I'm going to close those parentheses and square that, plus 3 minus 8, close that, and put my square. And I forgot to put the square up here. That's important. Got to square both of those quantities. Then I'm continuing to work it out. Square root of, and I have -5 minus -8. If you remember, keep, change, change, this becomes -5 plus +8. So -5 plus 8 is going to be a +3 squared plus 3 take away 8, or if I keep, change, change, 3 plus -8, that is going to be a -5 squared. Simplify that. continuing to write my square root symbol. Don't forget to carry that down and write that extra step so that at the end you remember that you need to square root it. So I have 3 squared is 9 plus 5 squared is 25. And then if you see up here, it says for me to give an exact answer, not a decimal approximation. What this exact answer means is that it wants us to leave it in the square root. So 9 plus 25 is going to be 34. So our final answer is root 34. And again, tomorrow your midterm will be multiple choice. So it'll give you that. Some might say this is an exact answer, square root, or it might say a decimal. Just make sure you're following those directions, but your options will be there. Okay? So this answer is the square root of 34. So question 9 is finding the midpoint M of the line segment joining the points C and D. And we have those ordered pairs there. Again, you will be given your midpoint formula. So that's going to be your x coordinates, x1 and x2. And you're going to divide those by 2 because you're finding the middle between those 2 coordinates. And then the same thing with your y values, with your y coordinates. You're finding the middle of those. Remember, your midpoint is that halfway point there. And your midpoint, it is asking for a point. So in this case, it's asking for the midpoint, which is a point, which is an ordered pair. So it'll have an x coordinate and a y coordinate. It's not just a number like your distance formula is, because that's a length. This is actually asking for a place on your graph, on your coordinate plane. So that's why it's an ordered pair. So what I like to do is I like to make 2 columns. I have my x column and my y column. And then I add my 2 x's together. So -8 plus -4. Divide that by 2. That's -12 divided by 2, which is -6. And then for my y coordinates, I'm going to say 1 plus -7. Divided that by 2 again because we're finding halfway. 1 plus -7 is -6 over 2. And then half of -6 is -3. So my ordered pair is -6 comma -3. That is my final answer. And one thing too is just by looking at this, I know my midpoint is going to be in this quadrant somewhere, right? On this line, -6, -3 would fall in this quadrant as well. So that's how I know I got my answer correct. So question 10 is asking to find the area of this trapezoid, and it's asking to include the correct unit in your answer. So again, your trapezoid area formula, so area of a trapezoid is going to be 1/2 times your height times the sum of your bases. And remember, your bases are the sides that are parallel from each other. So we'll have a base here, which will be 11, and our other base, which will be 3. Because if I look at these 2 sides, and these continue to go, they will eventually cross, okay? And then my height is always, it'll typically have a dashed line, and it'll form that right angle. So now I'm just plugging in what I know into my formula. I have 1/2 times 7 times 11 plus 3. And if I simplify that, that's 1/2 times 7 times 14. So then now when I'm simplifying, I'm going to have half of 7 is 3.5 times 14. And if I can just do this on my calculator. I have 49. I get 49 as my final answer. And since we're looking for area, this is going to be centimeters squared. Be careful on that formula. So you should get 49 centimeters squared. I do want to make a note. I did have someone ask about this 9 over here. Honestly, if it were asking for the perimeter, I would need the 9 over here. But for this question in particular, just asking for the area. So really that 9, we don't even need that information. Question 11 here is asking us to find the area of the triangle below. and to be sure to include the correct unit in your answer. So if you recall, the unit for area would be units squared. So in this case, our answer will have centimeters squared. And then our area formula for a triangle is area equals 1/2 the base times the height. So on this particular triangle here, I have my height, which is, it'll be that dashed line if it's not a perfectly right triangle, and that'll be 5. And then your base is always what your height forms the right angle with. So the base in this case is 15. So I have area equals 1/2 times 15 times my height, which is 5. I had someone ask about this last hour and they were like, what about the 12? Well, in this case, the 12 is unnecessary information. We do not need the 12. So that's just, they put that up there, but in this case, we don't need to know, we really don't need the 12 to find the area. So now in my calculator, I'll just do 0.5 times 15 times 5, and that gives me 37.5 centimeters squared. So question 12 is asking us to find the volume of the rectangular prism. So that formula for volume is length times width times height. So we have volume equals length times width times height. And since we have it doesn't really matter what we call our length, our width, and our height. We just have to multiply those 3 numbers together. So V equals 3 times 5 times 6, which gives us 15 times 6 if we're just simplifying, and gives us an answer of 90 yards cubed, because if you remember, we're doing also 3 times 5 times 6, which is yards times yards times yards, which we simplify to yards cubed. Question 13 is says the radius of a cylinder construction pipe is 2 feet. The pipe is 24 feet long. What is the volume? So it wants us to use the value 3.14 for pi and then round our answer to the nearest whole number. Be sure to include the correct unit in your answer. Before we begin, the volume of a cylinder can be found using the formula pi r squared times the height. Again, you'll be given this formula. So really we just need to know what's the radius and what's the height, or in this case, it's the length of the pipe, but if we turn the pipe perpendicular to what it is, it would be the height. So our height is 24 and our radius is 2. So now I'm just filling in what I know. V equals, for pi I'm going to put 3.14. For my radius I'm going to plug in 2, square it, and my height is 24. So I'm simplifying. I have 3.14 times 4 times 24. And when you type that into your calculator, you should get 301.44. And if I'm rounding to the nearest whole number, that would be 301 feet cubed for volume. Remember, your units are cubed in volume. So 14 is asking us to find the surface area of the rectangular prism and to be sure to include the correct unit in your answer. So again, our units for area are going to be units squared, and in this case our unit is a meter, so our answer will be whatever our number is, meters squared. Now we were finding the surface area and we had our nets. In this case we are given the 3-dimensional figure, so we have a formula for that, which we then at the end of finding the area, we looked at this formula, and it is surface area equals 2 times my length and my width, which will give me, if I outline this box and this box in red, so I have my length and my width, and there's 2 of them, that's how I get the 2, plus 2 times my height and my width. That would be if I had these blue boxes here. Those are my sides. Plus 2 times my height and my length, and that would be these boxes in green on the top and bottom. Then really it doesn't matter what you call your length, your width, or your height. Again, just label them. So I called my length is 8, my width is 9, and my height is 5. Then I just plugged it into my formula. So then I have 2 times 8 times 9 plus 2 times 5 times 9 plus 2 times 5 times 8. And now I simplify. 2 times 8 times 9, I got to be 144. Plus 2 times 5 times 9, I got to be 90. Saying 2 times 5 is 10, times 9 is 90. Plus 2 times 5 is 10, times 8 is 80. And I added all of those together to get 314 meters squared for my surface area. For problem 14, I want to let you all know it doesn't matter what you call the length, the width, and the height. If you call the width 8, the length 9, and the height still 5, it doesn't matter because the commutative property, addition and multiplication are all commutative. As long as you do 2 with 2 times 2 of the numbers plus 2 times 2 of the other numbers and 2 plus 2 times the other 2 numbers, doing all the different combinations which are at the top here that I just starred. So question 15 is asking us to find the surface area of a cylinder with a base diameter of 4 meters and a height of 3 meters. It wants us to use the value 3.14 for pi and do not do any rounding. Be sure to include the correct unit. As you can see, I wrote the surface area of a cylinder formula there. This again will be given on your formula sheet. So now I just need to plug in what I know. I know my 2 is given to us. I know pi is 3.14. For my radius though, I am not given the radius. I see my height is 3, but what it tells me is the diameter. So just to remind y'all, the diameter is all the way across. I need to know the radius, which is half of that. So 2r equals my diameter. So 2r equals 4, divide by 2, divide by 2. My radius is 2 in this case. So now I'm just plugging what I know into my formula. 2 times 3.14 times 2 times 3, which is my height, plus 2 times 3.14 times my 2 squared. When I do 2 times 3.14 times 2 times 3, I get 37.68 plus 2 times 3.14 times 4, because 2 squared is 4. Then I simplify the right-hand side of that, so I keep my 37.68, and when I multiply the right-hand side, I get 25.12. I add those together, and I get 62.8 meters squared, because it is asking for the area, the surface area.